everyone, Assalamualaikum. My name is EZATTE binti AMRAN and my metric number 2019-2627A and I'm from RES 123G.
Hi and Assalamualaikum everyone. My name is Syafiqah binti RIDZUAN 2019-278884 and I am from RAS 123G.
Hi guys, my name is FATIN SHAMILA binti Mazik from RAS 123G with the metric number of 2019-222786.
The magnitude of this electrostatic force Fe acting on two charged particles Q1, Q2 is expressed as Fe equals to K Q1 Q2 over R squared. There are three objectives of this experiment. First, to satisfy Coulomb's law experimentally. Second, to study the parameters that affect the electric force. And third, to find experimentally the electric constant K.
To satisfy the objective, do the following steps. First, the following link was clicked and the charge Q1 and Q2 were fixed and their values was written in the table 1. Second, the distance between the two charges was changed as shown in the table 1. Third, the force value for each distance was recorded. Table 1 was filled by finding R square and 1 over R square. Part 2. To satisfy the objective, do the following steps. First, the following link was clicked and the charge Q1 and the distance R were fixed. Their values was written in the table 1. Second, Q1 was controlled and it was fixed at 5 new Coulomb and the distance between the two objects was fixed at 6 cm. They were recorded in table 2. The charge of object 2 was changed as shown in the table 2 and for each Q2, the electric force between the two objects was recorded in table 2.
The purpose of this lab was to see how the distance between two charged objects affects the magnitude of the electrostatic force between them. If the object charge 1 get closer to the object charge 2, then the number on the scale will get higher. It is because the force between the two charges will be so strong since they are both charged. The results were when the distance between the charged object decreased, the number on the scale increased. Opposite charges attract each other, so since both objects were positive, they repel each other, making the force between them so strong, creating higher numbers as the objects got closer. Based on the experiment carried out in part 1, the distance between two charges was the dependent variable, whereas the electrostatic force was the independent variable. The charges Q1 and Q2 are fixed to 2 mu coulombs and 4 mu coulombs. These charges were moved to the different distance as shown in the table 1. After that, by using Coulomb's law, the value of electrostatic force was calculated. The value r squared and 1 over r squared were calculated and recorded in the table 1. The graph relates electrostatic force and 1 over r squared is plotted and linear graph was achieved. From part 2, the independent variable detected were the charge of Q2 and the dependent variable were the electrostatic force. From the graph, the electrostatic constant K was found by using Coulomb's law formula.
The force between 2 point charges is directly proportional to the magnitude of each charges, Q1 and Q2, inversely proportional to the square of the separation between their centers r, directed along the line connecting their centers r. As a conclusion, the objective of the experiment was achieved, were to satisfy Coulomb's law experimentally, able to know that the objective of the two charges, Q1 and Q2, and also the distance between the two charges, R, were the parameter that affect the electric force. The electric constant K that we found during this experiment were 8.99 times by 10 the power of 9 Newton meter square, Coulomb square, and all in all, this lab helped show why Coulomb's law is true. We understand that if you change the sign of the charge or the magnitude of the charge, it will change the electric field. The electric field has both a magnitude and a direction. Magnitude directly impacts the electric field and is dependent on how the charge is distributed in space. A line tangent to a field line indicates the direction of the electric field at that point. The value of electric field has dimensions of force per unit charge, and in SI system, the unit are Newton per Coulomb. Lastly, the strength of an electric field E at any point is the force F per units of positive electric charge Q, which is given in the equation E equals to F over Q.